Welcome to the lecture videos on Chapter 14 for College Physics 1 on the topic of sound waves. We are going to talk about what is sound. So first we're just going to be like what physically is sound, and then we're going to talk about kind of one property that is independent of the thing causing sound and only depends on how what the sound wave is traveling through, and that's the speed of sound. Then we'll get into some of the properties, like what physically relates to pitch and what physically relates to volume. And then, kind of completing our picture description of what they are, we're going to talk a little bit about how these properties can change as they travel. Okay, other than kind of the more obvious, if you just make a speaker play at a higher frequency or louder, how can you get this to change? And the volume can change as it goes outwards. The farther away you are from the wave, then the quieter you hear that wave be. So the further from the source, I should say. And we'll talk about how it depends on how the wave spreads. So we'll look at kind of three very simple cases where it just travels in one dimension, in two dimensions symmetrically, or in three dimensions symmetrically. And what happens to the volume as you go out, and how do we describe volume? The next thing we'll talk about is how the pitch can change based off of the relative motion of somebody who's listening and the relative motion of the person and the object that is making the sound. We'll look at this specifically in the context of sound waves, but this does actually apply to all types of waves, including light, for example. If you look up the formulas for light, you'll find they're a little bit different because you can use approximations that are, because light goes so much faster than normal objects, that are much more kind of simplify out the formula, and also because if you go near the speed of light, then we're going to have to whole another thing about relativity, which we're not going to go into. So the general idea holds up for all types of waves, though if you look at it specifically in other contexts, like light waves, you'll find a little bit of difference in the formulas that you'll see. Then we'll talk about a recap of interference from which was kind of gone over in chapter 13 as a way of leading us up to looking at two specific interference effects: standing waves and beats, which will be the two specific cases that we'll focus on in chapter 14. And that'll end our discussion of physics in general in College Physics 1.